Hey there, how are you guys doing? It's good to be here today. It is Friday. I like Friday, my favorite day of the week, because that means I have the whole weekend ahead of me. All right, my little french fries, we are going to talk about prime factorization today. All right, so if you were following directions so far in our unit, you have already taken these vocabulary terms and written them into your math notebook. If you haven't, that's okay. Maybe you missed that part of the directions. Go ahead and pause the video and jot all of these vocabulary terms down. There's 6 of them, okay? That way you can listen to what I'm saying instead of focusing on trying to write and not hear what I say, okay? So I did post a picture in the original unit, but if you didn't see that for some reason, then just go ahead and start jotting them down and pause it now, okay? So let's go over the vocabulary terms for everybody, and I'll just see if I can maybe explain a few things to go with the vocabulary terms. Okay, the first one is prime numbers. Prime numbers are numbers with only 2 factors, 1 and itself. Okay, so in order to understand prime numbers, you also have to understand this vocabulary term, which is a factor. Factors are the numbers that you can multiply to get another number. Okay, so let's go back to prime numbers, okay? So prime numbers are numbers with only 2 factors, 1 and itself. Okay, so let's think about the number 2. If you watched the video that I posted before this, you know that number 2 is the first prime number. And the reason why it's prime is because it only has 2 factors, and that means I can only multiply 2 numbers to get 2. And those 2 numbers are 1 and 2, which is itself, okay? Another prime number is 3, and there are only 2 numbers that I can multiply to get 3, 1 and 3. So 3 is itself. Okay, so if I'm looking at a number like 6, is 6 a prime number? Think about that for a second. Okay, so you should have realized that 6 is not a prime number, because I can multiply 1 and itself 6 together to get 6. But I can also multiply 2 times 3 and get 6. So that means it is definitely not a prime number. It means it is a composite number. So a composite number are numbers with more than 2 factors. So if it's not prime, it's composite, okay? So both types of numbers have a name. Prime, one and itself or its factors, and composite, it could have many, many, many other factors. A really big number could have a bunch of factors, okay? So those numbers that you multiply to get your prime or composite number, when you say 1 and 3 gives you 3, that pair of numbers is a factor pair. So a factor pair are 2 numbers that when multiplied, they equal a number. So for instance, 2 and 4, if I multiply 2 and 4, they're a factor pair for the number, think about it, you should have come up with 8, okay? So if I multiply the number 3 and 6, those 2 numbers are a factored pair for what number? Hopefully you thought of 18, okay? All right, so that's what a factored pair is. All right, now prime factorization, which is what we're really going to be working on today, is finding which prime numbers, not composite numbers, which prime numbers can be multiplied to find an original number, okay? And that sounds a little confusing, but once I give you an example and I show you, I promise it's going to be a little bit more clear to you. Okay, and then a factor tree is a graphic strategy for organizing how to find a number's prime factorization, okay? And I'm going to try and focus that a little bit better because it looks like it's a little out of focus. Okay, all right. So we're going to dig into that a little bit, but first I want to ask you a question. So let's say it's the beginning of the school year and I am actually going to have children in my class. I miss you guys. Okay, so let's say I'm having real kids sitting in my class, okay? And I have 24 desks in my class. And I want to try and figure out, how do I want to group my students this year? Maybe I wasn't too happy with how I grouped them last year. Maybe I liked how I grouped them last year. But I want to think, like, what are my options? Do I have any options on how to group my students? All right. So let's take a look at that really quick, okay? So let's say I have 24 desks. And remember, if I'm writing, you're writing. I'm going to make it a little bit bigger for you. Okay, so remember, if I'm writing, I'm writing. So if I'm writing, you're writing. So 24 desks. How can I group them? Okay, so the best thing to do is start low, okay? When you're thinking about factor pairs, you're going to start low. The first thing I can do is I can always start with 1 because 1 times something equals every number, okay? So there's a number that you can multiply times 1 to get any number. All right, so I'll start with 1. So if I start with 1, my factor pair would be 24, 1 and 24. And I'm going to write 1 group of 24, okay? And then, okay, so let's do 2. Can I divide 2 into 24? Yep, I can. 2 times 12 would give me 24. So I could do 2 groups of 12. Okay, how about 3? Can I do 3? 3 goes into 24 8 times, so 3 times 8. Yeah, 3 groups of 8. Okay, let's go with 4. 4 definitely goes into 24. It goes into 24 6 times. So I could have 4 groups of 6. Okay, so then technically I'm going to go to 5 next, right? But 5 doesn't divide evenly into 24. And I can't have 4 1/4 desks or, you know, a part of a desk. I have to have a whole desk, right? So there's no factor that multiplied by 5 that will give me 24, okay? So I know that I've pretty much stopped because my next number would be 6, correct? And there's no need to flip-flop them. But if I'm listing all of my factored pairs, I would stop. My factored pairs would be, sorry. My factor pairs would be 1 and 24, 2 and 12, 3 and 8, and 4 and 6. So those are my factored pairs. Okay? But just for the sake of answering the question, you have to remember that I asked how many different groups could we make with the 24 desks. So I could also, and I'm going to write this in a different color just so you understand that they're the same factored pairs, we're just flipping the group. So if I flipped it, it would be really weird, but I could have 24 groups of 1, couldn't I? So I could have 24 groups of 1 I could also have 12 groups of 2, which is usually how I set up my classroom. I usually do groups of 2. I could have 8 groups of 3, which I would like better than groups of 2, but we have these weird triangle desks. And I could also do 6 groups of 4. And if I added up all of those groups, then I could technically, there are technically 8 groups that I could choose from, okay? But as far as factored pairs, you have to understand that 1 and 24 is the same factor pair as 24 and 1, okay? So I only have 4 sets of factored pairs, okay? Okay, so let's practice a little bit with factor pairs. And let's just, we'll just try 4 little ones just to get us going. So 1, we'll do 1, I'm sorry. Remember, you're using pencil, so you can erase. Let's do 12, 2, we will do 17, and for number 3, we will do 24, and for number 4, we will do 25. Okay, so go ahead and pause the video and you try and find all of the factored pairs for those 4 numbers, okay? And then hopefully you just came back after pausing the video and you're not just waiting for me to solve them for you, because that's not the best way to learn. Remember, you actually have to practice yourself too, okay? So it's okay to pause the video, try them, and then come back and watch me solve them, and we can see if you got the same answers, okay? So, 4, 12 are factored pairs. Remember, I said start at 1, okay? 1 times what equals 12? 12. Okay. All right, let's go to 2. 2 times 6 equals 12. All right, does 3 go into 12? Sure does. 3 times 4. So those are my factored pairs. And remember, since I see how I got from 3 to 4, there's no number in between 3 and 4, so I know I can stop. Okay? All right, let's go to 17. So I said to start at 1. 1 times what number equals 17? You should come up with 1 times 17. Okay. 2. Is there any number times 2 that equals 17? No, because it's an odd number, so we know that right off the bat, right? Okay, how about 3? Does 3 divide into 17? Nope. 4? Nope. 5? Nope. 6? 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17? No, because it's what kind of a number? It is a prime number. Okay, when you guys see the hashtag, that's also called a number sign. Whenever you need to write the word number, you could use a hashtag instead. Okay, helpful way to make your notes a little shorter. Okay, so 24. All right, start at the lowest prime number. I know I have 1 and 24. 2 and 8, 3 and 6. Oops, oh my goodness. That was really bad. 2, my brain was thinking faster than my mouth was. 2 and 12, 3 and 8, and then 4 and 6. Hopefully you remembered that from the problem we just did. Okay, 25. All right, so I've got 1 and 25. 2 doesn't divide into 25. 3 doesn't divide into 25. 4 doesn't divide into 25. 5 divides into 25. And how many times does it divide into 25? Hopefully you said 5 times. Now, if I hit the same number, I'm done. That's it. There's no more. Because I can't go to 6. I've already passed it. All right. So those are my factors my factor pairs for 25. Okay, so now we're going to talk about prime factorization. And remember, we said that prime factorization was a graphic organizer or a graphic visualization that will help you find all the prime numbers that you can multiply to get the starting number, okay? So we're just going to dig right in and try it and see if hopefully you kind of understand it, all right? So for this example, we are going to write the prime factorization of 48. Okay. Okay, so the reason why we did all those factored pairs, the practicing with the factored pairs to talk about prime factorization is because knowing our factor pairs is going to help us with prime factorization, okay? All right, so the first thing that we're going to do, we are going to use a factor tree. Okay, and you have to figure what we're doing is we're starting off with the tree. This is like the trunk, and we are going to make branches from the trunk, okay? So 48 is the number that we are starting with, all right? Now, I need to find a factor pair, excuse me, a factor pair that will help me break down the number 48. And the first thing that I like to do, a rule that I like to follow, at least for now, is I like to start with the lowest prime number and see if that number goes into it. If that number doesn't go into it, then I move on to the next lowest prime number, okay? So remember 2, 3, 5, 7, 9, 11, and so on, okay? So I start with 2. Does 2 go into 48? Yes, it does. You should all know that because it's an even number. So we know it goes into 48. Okay, so 2 goes into 48. And it goes into 48 24 times. So 2 is under one branch. And 24 is under the other branch. So 2 times 24 equals 48. Okay? Now 2 is a prime number. So I'm going to circle it, okay? And by circling it, what I'm saying is that I'm done with that branch. I'm not going to touch that branch anymore. I'm going to leave it alone, okay? Okay, but my other branch is 24. And on that branch, it's not a prime number. I know that it is a composite number, and there are more, I'm sorry, my phone's ringing, so I'm trying to ignore it, but there are more numbers that will go into it, all right? So again, I'm going to start with my lowest prime number. My lowest prime number is 2. Does 2 go into 24? Well, yeah, we know it does because it's an even number. So 2 goes into 24 how many times? Should come up with 12. And once again, I'm going to do the same thing. I'm going to circle that 2. All right, so I'm done with that branch. Now I've got 12. Okay, so once again, I'm going to start with the lowest prime number, 2. And 2 times what equals 12? 6. And I circle my 2, so I know I'm done with that branch. I don't got to keep going back to it. Now I've got 6. Is 6 a prime number yet? No. Now, lowest prime number that goes into 6. Hopefully you said 2. How many times does 2 go into 6? Hopefully you said 3. Okay, and I know 2 is a prime number because I've been circling them, haven't I? And is 3 a prime number? Yes, it is. 3 is a prime number, so I can circle my 3. And what does that mean? It means I'm done. I can stop with my tree, okay? Now what I need to do is I'm not quite done. I did the tree, that's the strategy, but now the strategy has to help me get the prime factorization. So, remember I was finding the prime factorization for 48. So I'm going to write 48. Okay? And my prime factorization is everything I circled multiplied together. Okay, so remember how we said it was all the prime numbers that you multiply to get the original number? So that would be 2 times 2 times 2 times 2 times 3. Okay, so that sounds a little weird, right? Well, how does 48 equal 2 times 2 times 2 times 3? Let's do it really quick. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. And 16 times 3 equals 48. Okay, so, and hopefully if you remember from last week's lesson on exponents, there's a nicer way that we can write this, right? How many 2's do I have? I have 1, 2, 3, 4 2's. So I can write 2 to the 4th times 3. All right, so this can be my answer, or this can be my answer. I will tell you that this is the better answer. If you want to show me that you're really thinking and you're paying attention to math and you're thinking deeper, then this is the best answer, okay? Will this get you a check mark? Yes, unless I tell you to write it in powers, okay? But this is the better answer, okay? Okay, so I want to show you one more situation. So I said you should always start with like the lowest prime number, right? So let's try working out for the number 24. Okay? And remember, we're finding prime factorization, so we're finding those prime numbers, okay? So I said, always use the lowest prime number, and that way you can start off small and it's easier math, right? Okay, well, sometimes our brains just don't see it that way. So let's work it out the way I would normally do it. 2 times 12. Break apart the 12. 2 times 6. Break apart the 6. 2 times 3. So my prime factorization for 24 is 2 times 2 times 2 times 3, or 2 to the 3rd, or 2 cubed, times 3. Okay, so let's just say your brain didn't work that way and you totally forgot that you're supposed to try to find a factor pair with a 2. It's okay. You don't have to worry about it. So let's just say you found any factor pair that works with 24. So another factor pair that works with 24 is 4 and 6, correct? All right, so 4 times 6 equals 24, right? But 4 is not a prime number and 6 is not a prime number, so I can't circle them, right? I have to keep going. I have to keep working on both branches now. Okay, so 4. My prime numbers for 4 would be 2 times 2. Those are prime now. I know I could stop on that branch. Okay, so now what is a factor pair for 6? A factor pair for 6 would be 2 times 3. And I would circle my prime numbers again because those are both prime. And I know I'm done now. Okay, well now look, I did it. I started it completely different, didn't I? I started with a different factored pair. But I got the same result, didn't I? 2 times 2 times 2 times 3. Or 2 cubed times 3. Remember, I like to always put a square or a circle around my answer. Okay? So as long as you're doing the math right, as long as you're using true factor pairs, it doesn't truly matter which factored pairs you start with. So I told you that I like to start with the lowest prime. And the only reason why I like to do it is because it always kills a branch right off the top. If this was a very large number, we might have to do a very big tree. And so by killing a branch, you're going to do a lot less breaking apart. And you might be less likely to forget to break apart a branch, okay? So it's just preference. More than likely, when I show you how to do it as a sample, I'm always going to do that, but you don't have to as long as you're using good factored pairs, okay? We'll always get the same answer, and that's what really matters in the end, is that you get the same answer, okay? Okay, so I'm going to give you a few practice examples, and you're going to write these down. Okay, you're going to write these 4 down, and you're going to do factor trees for these 4 on your own time, and we're going to go over them together on Monday, okay? So let's do a factor tree for the number 26. Let's do a factor tree for the number 32. We'll do a factor tree for 85. Yeah, big numbers, right? And let's go even bigger. Let's go to 125. Okay? So write those down. And when we come back together on Monday, we're going to go over them together. So write them down, solve them, practice your factor trees, check your work. Remember, at the end, when you get down to those prime numbers, you have to multiply them back together. If it doesn't equal your starting number, then you know you did something a little bit wrong. So I love math because almost everything we do in math has a check. There's a way to check it. And so you can make sure you're right before we even talk again, okay? So go ahead and do that. And the next time we get together for a lesson, I will start our lesson with these problems and show you how I would solve them and see if we got the same answers. All right, guys, have a great weekend.